Hello and welcome to my presentation titled Examining Design Choices of Questionnaires in VR User Studies. My name is Dimitri. We as researchers often use VR for user studies, and frequently our measurements rely on subjective self-reports, for example questionnaires. Often users leave VR to fill out questionnaires on PC or paper and have to return into VR for the next task. The switch between realities creates a break in presence that can cause participants distraction and negative emotions, which in return can lead to biased results. Therefore, it seems natural that the administration of questionnaires in VR should improve the quality of a user study. When designing our own user studies and considering applying in-VR questionnaires, we were surprised that the assessment method received low attention in the literature. This indicates that the administration of self-reports in VR user studies requires some considerations in order to retain validity. To build an understanding of the current practices and to lay the groundwork for future development, we based this work on the following research questions. How are questionnaires and individual question items applied in contemporary VR user research? What are the considerations around and possible advantages of administering questionnaires in VR? What are appropriate design choices for presentation and interaction with in-VR questionnaires? These research questions are addressed in a series of 4 studies which I present in the following slides. With regard to RQ1, we conducted a literature review to investigate common procedures of VR user studies. We analyzed both the system design and the study design of 123 publications between 2016 and 2019 from Kai, Kai Play, VRST, IEEE VR, and IEEE 3D UI. 110 of 123 publications used questionnaires, 15 used InVRQs, and 7 described them in more detail. The realizations of InVRQs differ substantially in their presentation and interaction methods. The majority of cases use presentations that contextualize the questionnaires in the virtual environment, either attached to the users or anchored in the world space. Their participants used predominantly native controllers to interact in VR, directly followed by freehand interaction. These results indicate that there is no shared agreement on administration of questionnaires in VR. To augment the insights gained from the literature review, we conducted an expert online survey that evaluates general proceedings of VR user studies and attitudes towards InVRQs. We developed a custom survey to capture the experience with in-VR questionnaires as well as the potential problems to consider. For recruiting the expert participants, we contacted the authors from the literature review and advertised the survey on social media. 74 experts filled out the survey. After filtering, our sample consisted of 67 responses. The responses of the survey indicate that the experts appear to have a positive attitude towards in-VR questionnaires. Our expert survey did not highlight a clear standard method for presentation. Both our literature review and expert survey demonstrate that there is no common standard for using questionnaires in VR user studies. Thus, regarding RQ1, the state of the art for delivering questionnaires in VR user studies is quite heterogeneous. There are experts who have a strong opinion against embedding questionnaires in VR and argue that InVRQs are not usable or could bias the self-reports. In response to RQ2, the broad range of reasons provided for or against using InVRQs indicate technical challenges, implementation effort, fear of biases, and participant overload. The results from the literature review and from the expert survey are heterogeneous and do not allow for a definite answer on the validity and realization of InVRQs. With regard to RQ3, the goal of this design study was to identify the most usable interface design to further investigate the validity of InVRQs as a measurement device. We implemented 4 variants of InVRQs. The interfaces differ in 2 dimensions: anchoring as world-referenced and body-referenced, and interaction modality as pointer or trackpad. The world-referenced UI is anchored in the virtual environment and the users can freely move around the interface. A body-referenced UI is attached to the handheld controller. Our interface supports 5 common types of questions. The study has a 2x2 within subjects design where the users filled out InVRQs using the 4 different versions of the interface. Each condition consisted of a questionnaire that comprised 5 common knowledge questions with each question type represented once. After each condition in VR, the participants took off the HMD and filled out a paper-based system usability scale. 10 male game developers with prior experience with VR participated in the study. The SUS scores and the completion times clearly show that world reference anchoring with laser pointer interaction is the easiest to use and therefore the best candidate to investigate the concerns raised by the experts. To contrast the usability of InVRQs against OutVRQs, we conducted a user study with 38 participants. The participants shot balloons in a VR archery game and then filled out InVRQs as well as questionnaires presented on a notebook. As the design study revealed, we implemented the InVRQs with world-based anchoring and laser pointer interaction. The OutVRQs were realized using Lime Survey. It was presented on a 15-inch notebook with external mouse. As subjective measures, we assessed presence, task workload, and usability. Also, we logged task duration and interviewed the participants at the end of the experiment. For presence, the results show positive ratings of general presence, spatial presence, and involvement. There was no significant effect between InVRQs and OutVRQs on any IPQ subscale. Also, the variances between the responses didn't differ between the conditions. The duration of filling out the questionnaires was around 6.5 minutes, with InVRQs slightly but not significantly slower. Nevertheless, in the interviews, 5 participants perceived filling out the InVRQs as faster, and 2 had the impression that the questionnaires themselves are shorter. On the UMOOCs, the participants rated the usability of both questionnaire types positively. The InVRQs received a lower rating of 77 in contrast to 86 for OutVRQs. The participants experienced low to medium workload on the NASA TLX with higher physical demand and effort of InVRQs. From the qualitative interviews, we found that most participants enjoyed the VR experience and that the InVRQs were easy to use. A few highlighted that with the InVRQs the study feels more fluent and avoids breaks in presence. Roughly a third stated that InVRQs were entertaining, and if the participants would have to repeat the study, the majority preferred to do the question asking in VR. High ratings on the IPQ and the qualitative statements indicate that the game provided a high sense of presence. With the UMOOCs, we measured high usability scores for both questionnaire types. According to Bangor, the scores are in a highly acceptable range, discarding the usability concerns of the experts. However, the OutVRQs were rated higher with a medium effect size. A possible explanation was given in the interviews. Sometimes the participants had to repeatedly click on the UI element for selection. On the TLX, we measured a comparatively low workload. However, the physical demand and effort are significantly higher in the InVRQ condition. This could be attributed to the fact that the participants were standing and using the VR controllers in mid-air rather than sitting on a desk with resting hand. One participant even sat down on the ground to fill out the InVRQ. The comparable duration is consistent with the TLX ratings for temporal demand and allows to infer that answering questions in VR does not affect the duration of a user study. Subjective self-reports are frequently used in VR user studies and administered in the physical domain. This can lead to a break in presence, disrupt immersive experience, and bias the responses. To overcome these biases, we investigated how to embed questionnaires in VR from 3 perspectives: literature, experts, and users. From the literature analysis, we identified 15 instances of in-VR cues. These few examples differ substantially in visualization and interaction, emphasizing the lack of validated serving procedures in VR user research. For a comprehensive understanding of the advantages and challenges of in-VR cues, we conducted an online survey with 67 VR experts. To explore presentation and interaction modalities suitable for in-VR cues, we conducted 2 user studies in which we first identified world anchoring and pointing as most adequate design choices to administer questionnaires in VR. We then contrasted in-VR cues against common screen-based out-VR cues. Although the results show lower usability and higher physical demand and effort of in-VR cues, the ratings are within a tolerable range, and the majority of participants stated a positive attitude towards in-VR cues. Based on the results from the 4 presented studies, we conclude: researchers should apply in-VR cues in their user studies. Pointing and world anchoring are usable ways to realize in-VR cues. Participants prefer using in-VR cues over out-VR cues, and researchers should be aware of slightly raised physical and mental demands when using in-VR cues. In a follow-up study, we showed that in-VR cues can drastically reduce the break in presence. Therefore, similar to the establishment of standardized questionnaires that are empirically validated, we propose moving towards standardizing questionnaire implementation and presentation methods in VR. Thank you for your attention. For details, we refer to our paper. If you are interested in trying out questionnaires, have further remarks or questions, please contact us using the displayed email address.